Hello and welcome to another exciting pre-calculus video. In this section 4.4, we're going to travel outside of the first quadrant and find the trig function of any angle. Because up till now we've stayed in quad 1 where everything has been positive. In this section we're going to travel out of the first quadrant. We can find the trig function of any angle. In the day 2 video, we'll find what are called reference angles. And then this will lead us to evaluating the trig functions of any real numbers. Okay, let's look down here at this picture I have. Here's a point on that ray coming out of the origin. And of course, that point is going to be x comma y. So if I drop this down to sort of make a right triangle, how long is this side? Well, that is whatever our x-coordinate is. If the x-coordinate here is 3, that's the side of this triangle. If it's 10, that's the side of the triangle. And as we travel up, that is, of course, our y-coordinate. So we've got x and we've got y. We could use Pythagorean theorem to find this side, and you're going to see on the next slide, we're going to call this side r. R equals. And again, Pythagorean theorem would say we would square this leg, x squared, and we would square the other leg and add them up, and that would equal r squared, so we square root both sides. And the x squared and the y squared are under the same radical. So just like we could set up a triangle for opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, we can use the x-coordinate, the y-coordinate, and the r value to find any trig function we want of any angle. And here's how that looks. So let theta be an angle in standard position. X comma y is a point on the terminal side of angle theta. R value is x squared plus y squared underneath a radical. So the sine value is the y coordinate over the r distance, the distance from the origin. Sine is y over r. Cos is the x coordinate over the r distance. And then tangent is the y coordinate over the x coordinate as long as x is not 0. And we could find cotan by turning this one over, so that'd be x over y. Now the y cannot be 0. If we turn over cos, we get secant, r over x, as long as x is non-zero. And then cosecant theta is just the flip of sine, so that would be r over y as long as r is not 0. Notice in none of these they don't give you the stipulation like here r cannot equal 0, because by its very definition r cannot be 0. It's the square and the sum of the other two sides and square rooted. It's not 0. R is your distance from the origin. So the sine values and the cosine values can be negative depending on what quadrant we wind up in. Let's see here. Okay, now in this one, they give us a point, x comma y. So I'm just going to make a little list. My x is negative 3. My y value is positive 4. And we're going to go over here to the side, do a little scratch work to find r. Remember, r is, I'm going to put a radical here, and I'm going to square the first number. That's going to be a 9. And I'm going to add to that, square the second number. 4 squared is 16. You add those up, you get the root of 25, and the square root of that is 5. So here are the three pieces I need, x and y and r. And they're just asking us to find the first three: sine of theta, cos of theta, tan of theta. So sine, on that previous slide, we see sine is y over r, cos is x over r, tan is y over x, from right there. And now we just plug in our values. So let me switch to a red ink. Sine is y over r, that will be 4/5. Cos is x over r, that will be negative 3/5. There's the first time we see a negative trig function there. And then tan is y over x, that's going to be 4 over negative 3, negative 4/3. So there's our three trig values based on just having this point on the terminal side of that angle. The signs, either positive or negative, of our trig functions in the four quadrants can be determined from the definitions of the functions. For instance, because cos is x over r, let me write it here, cos of theta is x over r. And remember, r, by its definition, is never negative. It all comes down to the x value. If x is positive, cos is positive. If x is negative, cos is negative. And the same thing is true with sine, which is y over r. Sine is y over r. Our denominator is always positive. So if y is negative, sine is negative. If sine is positive, your y value will be positive. So here is our 4 quadrants, just what's positive and negative where. Quadrant 1, x's and y's are both positive because we're touching the positive x-axis. We're touching the positive y-axis. Over here in quad 2, x's are negative because we're now touching the negative x-axis, but we're still touching this positive y-axis. So y's are positive, now x's are negative. Down here in quad 3, we're touching this negative x-axis. We're touching the negative y-axis, so those are both negative. Over here in quad 4, we're touching the negative y-axis, so y is less than 0, but we're back to touching the positive x-axis, x is greater than 0. So one way to figure out what's positive where and what trig function you're dealing with would be to memorize this. In quad 1, sine, cos, and tan are all positive, so are their reciprocals. In quad 2, sine is positive, and that means its reciprocal cosecant will also be positive, but everything else is negative. Down in quad 3 now, tan is positive, as well as cotan. Its flip will also be positive, but sine and cos are negative. And in quad 4, cos is positive, sine and tan are negative, and remember the reciprocals will have the same sign as the original. So you can memorize that or this little trick to figure out what is positive. What is positive? All students take calculus. So in quad 1, all things are positive. Everything's positive. Over here, the S stands for sine, so sine is positive, and of course its flip cosecant will be. Down here, all students take, T stands for tan. Tan is positive, and its flip cotan will also be positive. All students take calculus. C stands for cosine. So cosine is positive, and of course its reciprocal secant will also be positive. Everything else is negative. So again, in quad 1, everything is positive, all 6 of them. In this quadrant, only these two are positive, sine and its cosecant reciprocal. Down here, only tan and cotan are positive. All the other 4 are negative. And in quad 4, cos and secant are positive. Everything else is negative by default. And if you don't like all students take calculus, you can always do add sugar to coffee. All positive, sine positive, tan positive, cos positive. Okay, now this one, they're giving us some clues. It says, given that tan is negative 4/5, cosine is greater than 0, find the sine and the secant. So, first let's figure out what quadrant are we in. Quad question mark. I'm going to just draw a quick little XY axis. And remember, it's all students take cooking. Let's figure out what quadrant we are in. Our first clue here is tangent is a negative value. So I can eliminate 2. If tangent's negative, I'm not in quad 1 where everything's positive, and I'm not in quad 3 where tan is positive. So those are out. Clue number 2 is going to refine it down farther. Cosine is greater than 0. Remember, cosines are paired up with x values. So over here, cosine is positive, so I guess that leads us right to quad 4. Over here, sine is positive, but that's not going to be. Okay, so we are in quadrant 4. So let's go back to this given value. The tan of theta is negative 5/4. So we know that tangent is the y-coordinate, so our y is 5, and over x, so our x is 4. Now the big question is, what does the negative get attached to? It could go with the y or the x. Well, think back to where we are in quadrant 4. Down here in quadrant 4, we are touching positive x values and we're touching negative y values. So positive x, we're going to leave the x as 4, and we're going to make this y into a negative 5. Okay, I'm back after pausing the video and I kind of lost my train of thought. So we've got the tan of theta 5 over 4. We've attached the negative to the proper one in the y coordinate. And of course, we're going to need our r value, x and y and r. And the r is easy. I'm just going to put a radical here. And I'm going to square the first thing. Well, let's square the x first. That's a 16. Plus, let's square the negative 5. If you square it, it becomes a positive 25. And if you add those up, that becomes the root of 41. Root 41. Okay. Now, they asked us to find the sine of theta. And sine is simply the y-coordinate over the r length. So in our case, that's going to be negative 5 over the root of 41. And if we rationalize, negative 5 root 41 over 41. All right. Now, the next thing they want is secant. And I don't have it memorized, but I know cos is x over r. And if we flip cos, we get secant. So the secant of this angle theta is going to be the r distance over the x coordinate. So r, root 41, x coordinate 4, root 41 over 4. And that's all they asked us to find, the sine and the secant. Okay, evaluate the cos and the tan function at all 4 quadrant angles, 0, half pi, 1 pi, 3 halves pi. So cos of theta is equal to x over r. Remember, r is the distance from the origin. We could use Pythagorean theorem, but really, it's not even a triangle. Here's the origin. How far away is any of these points? Each point is only 1 unit away from the origin because we're sticking right to the axes. So for all of these, r is going to equal 1. So let's do the first one. The cos of 0 radians is this x-coordinate, 1 over 1. That's just 1. Cos of 0, the next one will be cos of pi over 2. So now we're up here, and here our x-coordinate is 0, and we're going to divide that by r. 0 divided by 1 is 0. Sine cos, we're going to do another cos. This time we're over at pi radians. So now we're over here. The x-coordinate is now negative 1 divided by r is 1, so that's negative 1. And now finally we're down here at 3 halves pi, cos of 3 pi over 2. That's the x-coordinate 0 divided by the r of 1. That's equal to 0. So there's our cos values as we go around those quadrants. Now we're not done because they also want us to find tangent. Tan of theta is y over x. Tan is y over x. Oops. Tan theta equals y over x. So I'm going to go to my first angle, 0 radians. My y-coordinate is 0. That goes up top. X-coordinate is 1. That goes in the bottom. 0 divided by 1 is 0. Next up, the tan at half pi, pi over 2. Up here, my y-coordinate is 1, and my x-coordinate is 0. Uh-oh, look out, division by 0. That's undefined. Undefined. Now we're over here at pi radians. The tangent at pi radians is the y-coordinate over the x-coordinate. We can divide into 0. That's just equal to 0. Last one, we're down here again at 3 halves pi. Tan at 3 halves pi. That is my y-coordinate over my x-coordinate. Again, we're dividing by 0, so we found another undefined value for tangent. Okay. For these ones, let's cross out B from the huddle because it's kind of like what we're going to see down here. 19 there and 5B are very similar. So let's cross out B and just do A. So they got your X and your Y, find R, and then find the 6 trig functions. Here it says find the 6 trig functions. So they give us tan. We know it's negative. So that gives us a clue. We know sine is positive. That's another clue. So we can figure out the quadrant we're in. And that'll tell you where the negative goes. Does it go to the top or the bottom? The last one here, we did the last example for cos and tan. So here's sine. Find the sine at pi radians. And of course, you know to pause the video and then fire it back up and see if you got them right. So for number 5, x is 4, y is 3, and if you do Pythagorean theorem, r is 5. It's a 3, 4, 5 triangle. So our sine value is y over r, 3/5. And let's save that for the end. Cos is x over r, 4/5. And then tan is y over x, 3 over 4, 3/4. Now they did ask for all 6, so we could just, do our reciprocals. If we flip over sine, we get cosecant. That will be 5/3. If you flip over cos, you get secant. That will be 5/4. And then tan flips over to cotan. That will be 4/3. There's all 6 of our values just based on that point and our r distance. Okay. Here's my 4 quadrants. All students take calculus. Tan is negative, so I can eliminate the all and the tan positive quadrant. And here it says sine is greater than 0. Sine is positive. Well, here's our sine is positive. So it looks like we're in quad 2. We're definitely not in quad 4. So here we are in quad 2. And our tangent is 15 over 8, and that was negative. Remember, tangent is y over x. So if we're in quadrant 2, what's going to be negative? Well, it's touching the positive y-axis, so y is positive. We're touching the negative x-axis. So this negative is specifically attached to the 8. So if we've got x and y, we can solve for r. So I'm just going to make my list over here. X is -8. Y equals 15. R equals 17, if you do the Pythagorean theorem right. Now, in this one, they do say find the values of the 6 trig functions. So sine, I'm going to drop my angles. Sine, cos, tan, cotan, secant, cosecant. So tan they gave us, -15/8. Cotan is just the flip of that, -8/15. Sine is your y value over your r value, 15/17. Cosecant will be the reciprocal, 17/15. Cos is your x-coordinate, -8 over your r, 17. And secant will just be the reciprocal, -17 over 8. There's all 6 of them based on those 2 clues. Finally, we want the sine of pi radians. Oops, get up there. So here's my xy axis. Over here would be a dot. That would be -1, 0. And that is on the pi radian ray. So let's see. We want the sine of a value. Well, that's equal to your y value over your r value. Well, our y coordinate is 0. Our distance from the origin is 1 unit. 0 divided by 1 is 0. The sine at pi is 0. And if I recall correctly, that is the last thing we're doing here in this video. Look for the assignment on WebAssign, and next time we're together, we will do some odd problems.